welcome to my channel, The Machining Maestro. So today I'm going to explain you the facing cycle program in a Sinumerik controller for a CNC lathe machine. So before going for the programming, we should know that what is called facing. So generally facing in a lathe is a machining operation where a cutting tool moves perpendicular to the workpiece's axis of rotation to produce a flat, smooth and precisely cut end surface. So from this model, you can notice that this red highlighted portion is the amount of material we are going to remove through the facing program. And from this orthogonal view, you can reckon that this red hashing portion is the material we are going to remove. And the raw material dimensions are also available here. The dimension of the raw material is 40 mm its diameter to its 100 mm length, and the amount we are going to remove through facing is 10 mm. And this is all about your data. And then the next data is the tool, what kind of tool we are using here. So we are using here a indexable insert based cutting tool whose holder name is PCLNR 2525 M12, and the insert which is used over there is CNMG 120408. And regarding the tool and the insert, I'm explaining you in my next slide. Here is your tool details, and this is the tool in front of you, and this black portion is called the holder. The total black portion is called the holder, and this yellow portion is called insert. And the holder name, as I told you, is PCLNR 2525 M12, and the insert name is CNMG 200408. And this PCLNR and this CNMG, it has some meaning which is called the ISO designation of the holders and the ISO designation of the insert. So here I have given you some briefing about the tool, holder and insert, because this data we are going to use while creating a tool in our machine controller. And you see this red highlighted CL 12 C12 A08. This red highlighted data are the necessary data actually for the tool creation. So let's go to the holder. So in the holder, the P represents the clamping type. So here we have used the P type of clamping here. And when you come to the C is the insert shape, the shape of the insert or the angle of the insert, which is 80 degree. L is the tool holder type or tool holder's angle, which is 95 degree. The angle is produced between this surface and this surface, so that is 95 degree. And n is the insert side clearance angle. There is an angle getting produced at the side of the insert, which is called side clearance angle, and here it is 0. And R is the right hand cutting tool, meaning the head is pointing towards here, and in left hand tool the tool head is pointing towards in the left side. And 25 is the shank height. This is the shank, and it is a square kind of in shape. So the shank height is 25 here, and the shank width is 25 here. And M is the total length of the tool holder. So from here to here, this is the length of the tool holder, which is 150 mm. And 12 is your cutting edge length. Cutting edge length meaning from the side wall length of the yellow portion or the insert, which is 12 mm. Let's come to the insert data. C is the insert shape, again the insert shape or insert angle, which is 80 degree. N is the insert clearance angle, which I told you is 0 degree. Then M is the grade or class of tolerance, meaning inserts were manufactured with some class of tolerances. So M is one of them. And Z is the type of fixing or the chip breaking type. The inserts are also uh, meaning manufactured with a kind of fixation and kind of chip breaking style. So Z is one of them. And toll is the cutting edge length. Toll is the cutting edge length, meaning the side wall length of the insert. And thickness is 4 mm here, meaning from the thickness of this insert is 4 mm, meaning from here to here, you if you measure, you will get 4 mm thickness. And 0.8 is not nothing but the corner radius or the nose radius of the insert. So this is just a quick briefing regarding the tool, because this yellow highlighted data, so we require to create our tool in the machine controller. But the complete briefing and the complete details of the tool holders and the tool inserts, and different kind of tool holders and tool inserts, I will explain you in detail in my later videos. So stay tuned for that. So let's go to the machine controller, and we will create a tool over there. The machine interface. From here we will go to create our required tool. So for creating the tool, you click on this offset icon, and here the tool list which is appeared in front of you. You can see there are various locations in our magazine where the various tools are situated. So if you want to create a tool in any location, you just go there, delete that tool, or else you go there, unload that tool, or else you override that tool, also can be possible. So I'm going to show you how to unload that tool. So if you want to unload this tool, because we want to create our tool in location number 1, or else you choose the location where the tool is not available, based on your requirement you decide. So I'm going to create at location number 1, so you just go there and click on unload. When you are clicking on unload, no, so automatically the tool is getting unloaded. So later you can use that tool directly without creating a new tool. Later you can load that tool to your locations of magazine without creating a new tool. Or else if you want to delete this tool, so I'm going to show you how to delete a tool. You go here and click on delete. When you are clicking on delete, it is asking you, do you really want to delete this tool? Then you click on OK. So the tool is disappeared completely. See, when you unload it, the tool is available at the bottom, but when you delete it, no, it is completely disappeared from the machine. So I will do a tool creation. I can do a tool creation at location number 1 or location number 2 or else location number 7. If you want to overwrite a tool position, then you just also can do over here, that I will show you also. So if you want to overwrite here, you just click here. So when we are clicking here, no, it is going for the identifier options. From this option, you can choose your tool. So this is something we will discuss later. I will tell you in detail later. So for the time being, this is not required. I will tell you how I'm creating a new tool from a blank location. Okay. So go to the blank position, either 1 or 2. Here you go and click on new tool. From the new tool options, you choose roughing tool, because roughing tool, PCLNR is our roughing tool, and there are various cutting edge options over here. So you choose the first one, because our cutting edge position uh, will be this style or this way. Okay, so you click on OK. So it is asking whether you want to change the tool name. So I'm changing the tool name to PCLNR 25, 25 and 12. Okay, then press input. So now this is the sister tool options available over here, which we will discuss later also. And D is the cutting edge number, we will also discuss later. So stay tuned for that. In my coming videos, I am bringing all details about the tool creation and tool data, things like that. So next come to the next column, which is length x. Length x is nothing but it is the offset parameter, offset value between your workpiece diameter and the machine's x coordinate. So when you do the offsetting process, reference process, when you do the offsetting or reference process, no, that time automatically this x and z value getting stored. So since we are not doing any practical here, so I'm just putting a number over here like minus 200 or something. So in z also I can give minus 300 like that. Okay, so length I'm keeping minus 200, z I'm keeping minus 300, just approximately I'm keeping just for example I'm keeping. When you do the offsetting operation, no, that time automatically is a value will automatically restored over here. Okay, so so next go to the next column, that is radius. Radius is nothing but the nose radius. As for our tool data, the nose radius is 0.8. Then this is asking for the direction of holder or direction of cutting. So our direction of cutting is this, because our turret or tool is traveling from right to left, so the direction is okay here. If you want to look for the options, then click select, then various options will available here, so we are choosing this one and then input. Then in the next column it is asking for the holder angle. Holder angle is here 95 only. You write down 95, then press input. Then it is asking for the insert angle. As for the tool data, the insert angle is insert data, the insert angle is 80 here, so you write down 80, then input. Then it is asking for the plunger length or the cutting edge length. Cutting edge length, as I told you in my previous slide, that is 12 mm, so you write down 12, then press input. Okay, so next it is asking for the spindle rotation, but in lathe the spindle rotation is not required, because it is asking for the rotation of your tool, spindle rotation of a tool, which is required in milling. So here we do not need to activate that one. And coolant options are also available here. You can check on here. If you are checking on here, also you have to write the programming in your program. Coolant on program, coolant off program, you have to write over there. So these threes are not required for the time being. uh, but you can use the first column. So coolant is necessary for this tool. And the second option is, if you have any dedicated coolant supply option, then you can turn this on. So these three are optional, but these all parameters are really important. These parameters are really important, like this 12 mm is important, 80 is important, 95 is important, the direction of cut is important, the radius of the tool is important, and length x, length z is something you will get, or the value will be restored here when you do the reference or offset of the tool with the workpiece. Okay, so now next we will go and create the programming for the facing cycle. Next we are going to create the program for our facing cycle. For creating the program, you click on program manager, then out of this three directory you choose part programs directory, then click here, go to new, and define your program name. I am giving the program name facing, then click on OK, and this is the program interface in front of you, where you need to write your G codes, M codes, and cycles, etc. In my view, the program is comprises of four steps. The step number one is the creation of the workpiece, and the second step is writing down the pre-operation commands. The third step is creation of the cycle or defining the cycle parameters. Then fourth is writing down the post operation commands. And for creating of the workpiece, you should click on various, then click on blank, then choose the blank type. You see, out of these types, our blank type is cylinder only, so you click on cylinder. XA is nothing but your raw material diameter, which is 40 as per our drawing. Then after writing 40, you click on input. Then ZA, ZA is the starting length of your workpiece, which is 0, because this is the coordinate system of your workpiece, and here the Z starting Z is 0, and this side is in negative direction and this side is in positive direction. So ZA is 0 here. After that, press input. ZI is the total length of your raw material, which is minus 100. Why minus 100? Because Zi is in the negative side. So minus 100, and you keep this absolute, then click input. ZB is the length you are keeping for the machining outside the job. So meaning how much material you are keeping outside the jaw for the machining. Since we are going to do up to minus 10 mm facing here, so you should keep the values more than minus 10. So you can give minus 20, minus 30, like that. Should be more than minus 10. So I'm giving minus 30. Then press input and then select accept. After that, press input, then you write down the pre-operation commands. So in my pre-operation command, the first G code is Z90, which activates the absolute mode. Then you write down Z71, which activates the metric mode, meaning all the dimensions here will be in mm. Then you write down Z95. Z95 is your feed in mm per revolution. Then you write down G64. G64 is your continuous path mode, where the machine attempts to maintain a constant velocity across the block transitions. Then click on input, then write down the homing program T0 D0 Z0 X0 Z0 Z0. T0 D0 meaning uh, tool cancel, offset cancel, or tool cancel or cutting edge cancel. Then Z0 is the rapid movement of your x-axis. Z0 Z0 meaning rapid movement of your z-axis. So when you are writing down T0 D0, it means the all the tools got cancelled and the machine coordinate system automatically gets activated. And when you are writing D0, meaning all the cutting edges available in the machine offset parameter, those got cancelled and the machine coordinate system gets activated. Then you are sending your x-axis and z-axis to their homing position rapidly by writing Z0 Z0 in both the blocks. Then after that, press input, then choose your tool here, or call your tool here. For choosing or calling your tool, you click here, you click on edit, then select your tool, then choose your tool type. As you know, we have made this tool, so you select this tool, or else if you want to select this tool, select this tool. So if you want to select this tool, you click here, then click on OK. See, automatically the tool is appeared here. Now press input, you write down the spindle rotation program here, which is M3S800. M3 is the spindle rotation in clockwise and S800 is the spindle RPM. Then press input, then write down Z0 Z2.0. It means we are sending the Z axis to 2 mm away from the workpiece. So it will travel from its homing position towards the workpiece but stays 2 mm away from the workpiece face. And then write down Z0X 42.0. Why 42? Because since your diameter of the raw material is 40, so I am keeping 2 mm as a safety. And here Z2.0 meaning Z is all the starting position of Z is always 0, so I'm keeping 2 mm safety. So these two are called as a safety distance before approaching towards machining. So after that, you write down M7. M7 is the coolant on. So before machining, you should turn on the coolant. Then after that, press input. Then you choose your cycle. Press on turning. Then click on stock removal. Then define your safety height, safety distance or safety height. That is should be 1. Then okay, you can give 1 to anything. Then then it is asking for the feed rate. Feed rate, I'm giving here 0.2. You can give 0.1, 0.2, 0.3, like that. I'm giving 0.2, or else we can give 0.15 or 0.3. Then press input. Then choose the machining type. These two are like the first inverter triangle is represents the roughing operation, and this three inverter triangle represents the finishing cycle. So since we are doing going to do roughing operation here, so click on this. If you want to go look for the options, no, so you go here and click on select. Then automatically the options available here will appear in front of you. Then choose here by using your arrow keys, up down left right keys. Then click on input. Then it is asking for the position of the machining. So again you click select here. Then there are few options available here. So the first option is the external turning operation, and the second one is the internal turning operation. So since we are doing the external turning operation, so we will select this one. And these two are like when your chalk is like in right side and your turret is in your left side, then you select these two. Out of these two, you select accordingly. But since we are doing the machining process in a machine where the chalk is in left side position and my turret is in right side position, so I'm choosing this one. And mostly the machines available in the market is in this form only. So we are going to use these two only here. So for the external machining process, I'm choosing this one. So next you go here, then press select. So it is asking do you want to do the facing or the longitudinal, meaning turning. But we are doing the facing operation, so you choose the facing here. Facing, then press input. Then x0, x0 is nothing but the diameter of your workpiece. So you see the this marked position is the place where it is asking for the coordinate value of x. X is 40 here because the diameter of the workpiece is 40 here as for the drawing, so I'm writing 40. Then z0, at this position the value of z is, see, this is the datum position, value of z is here 0 all the time. Then x1 is the how much diameter you want to maintain in facing. So as you know, in a facing operation we don't maintain the diameter, we maintain the length, or we clean the face of the workpiece, or we we maintain the length of the workpiece, like that. So xa is should be 0, but to avoid the formation of peak after the machining process, because of the tool's nose radius, you should write -1 or -2. -1 meaning the tool will travel from here to uh, to the -1 position, which is beyond your uh, x0 position. In that way you may not see the you won't able to see the peak after the machining. If you're writing 0, no, so but writing 0, due to the tool's nose radius, you may see the peak over here. So to avoid that, you try to write the x1 value uh, meaning less than 0, which represents the crossing the 0 position, or the datum position, or the center position. Z1 is the how much length you want to do the facing. So I'm giving here -10, because as for the drawing we want to do facing up to -10. So this represents the how much length the tool should travel, and x1 is the how much length in x-axis, up to how much diameter the in x-axis the tool should travel. So these two are the uh, values we should focus in our we should focus more. D is the incremental depth of cut. Incremental depth of cut or maximum in-feed depth, meaning if you are giving 0.2, no, so incrementally 0.2 in first cycle, in second cycle it will take again 0.2, which is 0.4, then again 0.2, 0.6, 0. Like that it will go. So see, in the facing operation, it is taking one step over here. So this the difference between D is the difference between the two passes. So since we are going to do mine up to -10, so if I am giving 0.5 or 1 mm, if I am giving 1 mm, it means it will take 10 cycles to complete. Okay, so incremental it will take 1 2 3 4 like that. If I'm giving 0.5, no, 0.5 meaning it will take 20 steps. It will take 20 steps or 20 cycles will be performed in front of you. So let's keep it 0.5, or else keep it 0.2. 0.2 meaning how many times, 50 times, because 0.2, 0.2, 0.2, 0.2 like that, up to 5 times meaning 1 mm, then 10 times meaning 10 mm, so it means 50 times. Ux is the allowances you are keeping at the diameter of the workpiece. Ux is the Ux you see Ux is the allowances you are keeping. So allowance is required when you are maintaining something, but we are not maintaining the diameter here. That's why we should not keep the Ux value 0. So keep the Ux value 0 only. Uz is the amount you are keeping at the wall of the at the wall, or at the length, or at the face of the workpiece. So this is the uz part. So uz you give 0.1 because you may need to do the finishing operation after that. So to do that, you should write some value over here. So it will keep 0.1 mm material here. So instead of up to -10 mm, it will cut up to -9.9. Then 0.1 it will leave for you for the next cycle, if the programmer or the operator wants to do the finishing operation after that, no. So this 0.1 allowances will be removed in the finishing cycle. So after that, press accept. See, your cycle got created. Then press input. Now write down the post operation commands. Post operation commands are like Z0, Z2.0. So I'm pulling out my tool up to the Z safety distance, which is Z2.0, like the safety we have used over here. Then write down M5, M9. M5 is your spindle stop and M9 is your coolant stop. Then you write down the homing program, which is T0D0, Z0X0, Z0Z0. So we are sending our tool to their homing position, like we used to do at the earlier. The same way you do here. Then after that, click enter, then write down M30. M30 is your program end. So for the ending of program, M30 is important. You write down M30 to uh, give a command to the controller that you are ending your program. Okay, so this is all about your programming. Now we'll check the simulation. You click on simulation here. So click on 3D view. You see the tool will come here and it will do the machining. Okay, so it is taking different depths here. It is taking different depths, you see here, and from side view also you can understand. Okay, so since we have given 0.0.2, no, so in one pass it is taking 0.2, then retracting up to the safety distance we have given, and then again taking 0.2. So 0, in this way in each cycle it is removing 0.2, hence it will remove the total depth of cut up to minus 10 mm, mm, incrementally of 0.2 mm value. Okay, and at the last cycle, it will keep the 0.1 mm material for you for the finishing cycle, since we have given the allowances over there. Okay, so if you want to mm, zoom also, you can give. Okay, so it is doing the facing operation. So total depth it has see minus 9.9, then tool has gone. So this is all about your facing operation, and the facing has done. And from side view you see this is the 0 position and this is the minus 10 position. It has removed the material up to minus 10 mm, not minus 10, it is actually a minus 9.9 uh, by removing material 0.2 incrementally. Okay, so this is all about your programming. So for to run the program in your machine, you have to click on execute. Then the program will come to your machine screen and auto mode gets activated. Then you press on cycle start and your program will run in the machine. So if your offsets are okay, if your tool creation is okay, then you take first you create the tools, then you create the offset. If your offsets are okay, then you can create this program, you can run this program. Now you can define your depth of cut accordingly, and total depth of cut also as per your wish, and based on that you can do some changes and you can do the machining process. Thank you very much.